Embedded Controller Lab, we will look at how to simulate Part B program using a Proteus tool. I'm using Proteus Design Suite 8.9 version. Uh, First procedure, go to File, New Project. I'll get this option. So here select the root directory where you want all the projects to go in. So in my case, it would be in E. Created a folder Proteus, so this would be my root folder where I want all the projects to sit in. So let me define the project name as LCD version 1, LCD version next. And here first what we do is create a schematic, give next, then do not create a PCB layout, next no firmware project. So ensure that this is your structure now, schematic, no layout, no firmware, give finish. So get the layout displayed. So this is your area where you can add your devices, plug, connect and get your application running. So first I'll go to this button, which is to pick the device. So click on this, you get a new window displayed. So type the keywords which you want. So I'll just write ARM. So on typing ARM, you get the related components on ARM. So the relevant IC which I'll be picking is LPC 2138. So select this device, add onto this access region. The next device which I'll be picking is LCD. So this project is to program a LCD, hence this is the module which we'll be using to send the signal. So on this we select 16 by 2 alphanumerical LCD, pick this device, let me add it down the line here, and this is having 14 pins, whereas the physical IC which we are using has 16 pins. And the next one device which we require is a battery supply to trigger this controller. So again go to pick, select cell, and now here you have a battery, single cell, select the cell, add it here, and let's change this voltage, should be 3.3 volt, and connect this to the battery terminal of your microcontroller first thing, and VSS to the ground, and one more is this V3 line, so this should also be connected. So V3 should also go to this 3.3. So this would be done. So this much is actually your power supply which you need to give it. Along with that, you can provide the crystal oscillator frequency, which is 12 megahertz. So we will not do it because this can work without that also. But indeed, if you require a crystal oscillator frequency to be given, you can define it over here. Okay, now this over here, the structure what we follow here is, I'll just address. Based on that, I'll give the connection. So port 0 I'll be using because we have 31 pins of port 0 can be used. Similarly, 15 pins of port 1 can be used. So since we have more pins on port 0, I'll be using this port for connecting it to this LCD. So here, let me begin with port 0 10th pin. Port 0 10th pin and port 0 13th pin I'll be using. Port 0 10th pin I'll connect it to your register select line. Okay, so RS goes and it gets connected to P010. That's your first connection. Then we use enable, that's your 13 pin number 13, and pin number 13 goes to P013. Sorry, P013 enable. So enable and RS is connected, and RW we will make it low because RW stands for register select, and register select pin has to be grounded. Sorry, it is RW stands for read or write, sorry. So it should be grounded because we are writing it into LCD module. So pick this terminal device under this terminal nodes, ground, and you can place that component down here, and RW connect it to ground terminal. It's grounded. So okay, this is the connection for setting the control signals. Now the data signal D0 to D7 connected directly from P0 16 to P0 23. This many, you have 8 pins here, so everything we can use. So begin from P0 16. P0 16 is connected to D0. P0 17 is connected to D1. Similarly, make the connections. Okay, this is your hardware connection. After this, you have to go to your Keel project, and you have to write the program to drive this hardware. And same program which was discussed will be made use with a little bit of modification, because we will be using port 0 rather than port 1, which was used in your part B experiment. Okay, so hope the connection is fine. So P0 10 is connected to RS, P0 13 is connected to enable, RW is grounded, and the remaining pins starting from 16 to 23 is connected to the data lines of your LCD controller. So this is the connection, hardware connection. Now let's move back to the project. So here, select the proper controller here. So what we do is go to file, new project. So we create a project in the folder, ARM folder. Can select any folder, since it is a part B experiment, and the folder name I'll define it as LCD version 1 whatsoever. Then this will be the created new folder. The project name will also be LCD version. And here LCD version folder, let this be the project name. Saved. So it is saved. Now next go to NXP LPC 2148, you have to select now. This is due to the fact we are using 2138, its equivalent controller in Proteus machine. So select this LPC 2148, give OK. So it will prompt the message, do you want to add startup file? Give startup file, add the startup file to the project. So this is your startup file for LPC 2148 controller. Next go to source and go to file and create a file. This is the program, LCD program you can paste. So my case, I have the program here, and what modification needs to be done we will discuss, and before that we will copy this whole bunch of line to my working environment here. Okay, these are the comments, so I'll just delete, I'll erase this. Okay, so the first modification in this project is select the proper header file. So instead of 17xx, you select 21xx. No change here, so almost all methods will work. Next, coming back here, I'll just give the name something like VCET, ET, EC. Anything can be given here, and just let it be Puttur. And here I'll select 81, one pixel area I'll skip. Let me begin from the second column onwards, starting in row 1 and as well as in row 2. We will begin at column number 2. Okay, so this is no problem. So here this directional flag has to be modified, since we are using port 0. So this should be just addressed as IO directional flag for 0th port, and here we can make it FF, no problem. But since our pins are defined from 10th line onwards, first 2 I'll make it 0 till 23 it reaches. So the last pin also I'll set it as 0. Last 2 also you can set. Just for avoiding the confusion, we will ensure that this is the number which we will be feeding. No issues, even you can make all F and you can verify what's happening. Okay, now here the data lines goes from pin number 16 onwards, so this should be modified 16. And here in your experiment there, the port 1 was from, 13, 15, 16 and 17. They were actually the lines connected to the control pins. Here it is 10 and 13. So to modify that, here I am supposed to add a value. Instead of 2830s, here you put 2400. So 2400 ensures this 20010. It triggers the enable pin, and this is making the data line, which is register select line, will be made 1. Okay, here we make 0, and this one should be 4 because enable should be pulled low, and a register select should be made 0, 1, sorry. Okay, so that's all. And here you have to select now LPC GPIO1 will not work. Instead we will be using IO directional flag 0. Similarly, not sorry, IO pin 0, it should be IO pin 0. Similarly here IO pin 0, it should be 400. Now same code has to be addressed here. So here I'll just make 16. This is for command, so command only one difference, enable line same, whereas register select is always 0. So this should be 200, and this is all zeros, and here thing is again copy this IO pin 0, copy. So this is the content which will be replaced by this content. Okay, after this modification, one more modification you have to do. That is here string length no more works for this program. So we need to compute the string length using a pointer concept. Once we get that, that would be set as length. Okay, I repeat, string length is not gonna work. So what we will do is we will use a while loop, while because message is actually the pointer which will be pointing to the starting character. So we will check whether the content first character is it equal to null character. So doing that is done with the help of this command. If star message is equal to null character, if that is the case, what we have to do is we have to increment the length, as well as we will increment the pointer to, so that it can point to the next location, next character. So after doing this, the pointer direction has changed to, we want that direction to be set to the first character position. So that is done using the command. Anyway, length we will get, so I'll just use message minus length. This will ensure that the pointer again goes back to the initial location. Initial location here happens to be the starting character of a string, so there it will be pointing. Okay, no more changes, that's all. Okay, after this we will save this file. I'll save as, and add it to this folder itself. So LCD program, give the extension .c. That's all. Now this is your program. Now we will create a hex file out of it. So for creating a hex file, so first add this C file to this project. So it has been added. After this, go to file and select options for your target, and here frequency is 12 megahertz, status set, no problem. Output create hex file, select this option, and in the linker use memory layout for target dialog, select this option. Okay, after this much, that's the procedure which we need to worry about. Rather than that, everything is fine, if I'm not wrong. Okay, message length minus, okay, fine. Now we will build this code. This is okay. When create the hex file, so it has created the hex file. Now go to Proteus. Now we need to load the hex file, so we know what is the folder name. So this is your project LCD version. Under that, fetch the file .hex file and dump it onto this IC. So to dump the code onto this IC, double click on this IC, and you have the option here for adding your hex file. So select this option, program file, browse, and now go to R, because that's the position where in my case I have created my root directory. ARM part B, yeah, ARM part B, the file name is LCD version 1. This is the recent created one, and this is your hex file which you need to load. So after pressing this, you select OK. Now the code is dumped into this IC. After that, run your module. Okay, there should be a problem. 1 second, we will figure out what is the problem. 1 second, let me go back. Okay, the problem was in this code. I was supposed to use here not equal to. I had used is equal to null character. It should not be equal to. So that is the only one line which I have modified. Other than everything is good. After this, you can compile. You can build hex file. Then you can go back to this IC again. Let me, um, you know, double click on this. Select the hex file, open, and now give OK. Now I can run the program. So I'll get the result VCET Puttur. VCET Puttur. So first line, there is a problem, no problem. So you can just check with 80, so it will work. Okay, thanks for watching.